Velumani sir, can you hear my voice?
Yes, sir. Yes, sir. We can hear.
Okay, right, sir. I'll go ahead and introduce the speaker, sir.
Yes, sir. Yes, sir. So, good morning to all. Today we'll start the session. Second day's FDP session by Engineer Pravinjith sir in the topic of waste to energy by co-digestion of solid waste and septage case study. So before starting the session, I would like to introduce my coordinator, FDP coordinator, Professor Manish Shashikant Darik, and also I request him to introduce the today's speaker, Engineer Pravinjith also. Please proceed, sir.
Thank you, Velumani sir. It's a privilege for me to introduce to you all the speaker of today's session, Mr. Pravinjith K P. Mr. Pravinjith K P is currently the Managing Director of Paradigm Environmental Strategies Private Limited, a leading consultancy firm operating pan-India and in 5 other developing and 4 developed countries. Pravinjith is one of the founder directors of this firm, which has successfully completed over more than 300 projects in the field of waste management, wastewater management, climate change, and other environmental management related topics. He is an engineer with more than 28 years of experience in the field of energy and environment, wherein he's worked with leading institutions like Tehri, Kirloskar Electric, Subhash Projects and Marketing Limited, GIS. So, in addition to several private sector organizations, he is currently the international expert at GIZ India. He has also worked as a lead professional in several projects of UNDP, UNICEF, World Bank, Asian Development Bank, ADB, SIDA, USAID, DEG, BORDA, and other bilateral agencies. So, Mr. Pravinjith has successfully completed more than 350 infrastructure design and PMC consultancy assignments, wherein he has worked with the teams from Germany, UK, Netherlands, USA, Kenya, and various other countries in various capacities as a trainer and consultant. He has also rich domestic experience working in more than 15 Indian states, which include Jammu, Himachal Pradesh, Delhi, Rajasthan, Maharashtra, Goa, if you to name. His private sector clients also include reputed companies like Toyota, Pepsi, Cola, Tata Motors, and Siemens. Mr. Pravinjith also has been a lead consultant to several prestigious projects like Jainaram Municipal Solid Waste Project for 7 Jainaram cities undertaken by GIZ and Ministry of Urban Development, Government of India, wherein he was involved in establishment of integrated MSW approach in the cities. He has also experience in the field in the preparation of request for proposal RFPs and tender document, bid evaluation, contract agreements for more than 15 projects. So his expertise in water and wastewater management, and he has also been able to complete more than 200 projects in with respect to rainwater harvesting, sanitation. His experience in hazard, he has also quite good experience in hazardous waste management and e-waste, and he has been involved in concept to commissioning and operation of Karnataka's hazardous waste treatment, storage and disposal facility, which is TSDF for Karnataka, which is a state-of-art project implemented under the guidance of KSPCB, Karnataka State Pollution Control Board. Mr. Pravinjith is a master degree holder in geotechnical engineering. He is also presently pursuing his doctoral studies and master in business law from National Law School, Bangalore. He is a fellow of Institute of Engineers India and life member of Institute of Geotechnicals India. Mr. Pravinjith and his firm has also been a recipient of several awards. So a few to name: first prize in National Water Awards in the year 2019, which was awarded by the Honorable Minister for Water Resource. river development and Ganga rejuvenation from the central government for Kundalhalli Lake rejuvenation project. He has also recognition under National Urban Awards 2008 for Adarsh School, Badlapur, from Honorable President of India, and he is also the recipient of Nagar Ratna Award for City of Nashik from Government of India. So this was the profile of Mr. Pravinjith. So over to Mr. Pravinjith to deliver this session. We all are eagerly looking forward for your presentation, sir. Thank you. Please go ahead, sir.
Thank you. Thank you for the kind words. Yeah, so I am Pravinjith. I am the Managing Director of Paradigm Environmental Strategies in short. We have been a consulting company, although we are a firm of civil engineers and environmental engineers. We chose this line of environmental consulting for a simple reason that the whole topic of this workshop is about sustainability, and there normally engineers always prefer to go by the technical sustainability. Hello, one minute please. Yeah, so normally engineers prefer to go by technical sustainability and financial sustainability, and usually the environment and the social is always given a go by. Yeah, so that is one of the reasons why as a world we are all struggling, and in India especially it is a little not in a very good state. So if you look at the global environmental consulting opportunities, currently it is around $34 billion US, and India as only is in the 8th position with a very low number of 2%. 2% of the world's environmental consulting opportunities are in India, only 2%, whereas the opportunities are much higher. And there is something called the environmental performance ranking, and India is among all these 200 plus countries. India is in the 177th position as far the environmental performance index is concerned. Yeah, and we are positioned along with all our neighboring countries, Pakistan, Afghanistan, Iran, Iraq, and some countries like Kenya. We are in that group, almost at the bottom. Yeah, and there's only one country in this whole world from Asia who are in the top 50 rankings of environmental performance, and that's not in India also. So this is the situation of the environmental consulting companies. So we decided to enter this field, which is a very niche market. Yeah, so I'll just give you a small profile of Paradigm, what projects we are involved with, and then go on to the topic of the today's seminar. Is this screen visible? Hello?
No, sir, screen is not visible now. Yes, sir.
Is it? It's not visible yet?
Not visible, sir.
Is it visible?
Yes, sir. I think it is on process now.
It's visible, sir. Go ahead, sir. Go ahead, sir.
Yeah, it's visible. Okay. Thank you. Thank you. So the topic for today is waste to energy. I'll just give you a small overview of the interesting project we have done over the last 12 years. But primarily, this SDG goal, I think, which you have heard about in the introductory remarks with the principal and the professors, we have the 17 goals And we are trying to work in this 17, although not in all, but at least directly in five visible direct areas, and somehow related to the rest of the goals. Okay, so as I told you, the concepts of sustainability is hinged around these three pillars: environmental, social, and economic. Economic normally is taken care, not fully, but somehow when you do the financial analysis, you look into some part of the economics, but environmental and social is something which is normally not considered, although now the rules are strong on environmental, and many companies also assess their performance by the environmental and social performance. So eco paradigm is working in the field of research, consulting, implementation, optimization of designs, maintenance, environmental training, and social expertise. And primarily our focus areas are water and wastewater, solid waste, energy, and climate change. Now, like the introduction, we have worked in over 300 projects and across almost 9 countries across 5 continents. And these are our, except for South America, we have worked in almost all the continents, and we have worked in all the states in India. Some of our valuable clients, right from BBMP to KSPCB to World Bank to National Mission for Clean Gaga, we have worked with very prestigious clients. Private sectors are like this. These are all very interesting projects which somehow capture our vision of meeting this SDG goals. Yeah. So as of now, we have, this is little dated. We are treating close to 20 million liters of wastewater today. Every day, our projects treat so much. And solid waste is close to 10,000 tons is where we have given the consultancy. We have also helped prepare the policy document for Government of India under this nationally appropriate mitigation action plan, which is for climate change. We have done the RDF utilization for India. So a lot of policy project we have done, because finally policy actually helps in preparing the roadmap for a country. So some of this interesting project on water is this climate change impact on Nagarjuna left bank canal for ERM. And then we have also done the social sectoral environment and social assessment SESA project for 24/7 water supply for Hubli, Dharwad and Belgaum. And rainwater harvesting for Chinnasamy Stadium, Unkal Lake, that is under process. And this is the Chinnasamy Stadium where we have done the rainwater harvesting. They are harvesting about 36 million liters. Some of our favorite projects are Toyota Boshuku, Toyota Enki, Toyota Kirloskar. These are all different rainwater harvesting projects, small and big. Our specialization is ensuring that the environmental sustainability is there, but including the economic, because rainwater harvesting can be done in many ways. It has to be, if you look at the potential versus the investment, it should be really, you should get the value for your rupee. This is our Toyota project, Kirloskar project, where we helped Toyota reduce 90% of their water consumption, fresh water consumption. It's one of our largest project. This is a project which we got the National Water Award. The first prize is for rectification, rejuvenation of one lake in Bangalore, Kundarali Lake. Along with that, we have done several other projects in Bangalore itself. One tributary of river Aji in Gujarat, we have helped do it. It's a small pilot project, but to showcase a scheme where you can treat wastewater and turn it into a resource. So this is another project. We have done this environmental assessment, water auditing and environmental assessment of the all the major ports of India. There are 12 major ports, so we were involved in 3 of them in Tamil Nadu and 3 projects. So this is under the Indian Port Authority, Ministry of Shipping. And this is a nice, interesting project, which is on saving a river called the Karamana River, which was polluted, and the NGT had given strict instructions to the government of Kerala to rectify or solve the problem. So we have given a policy action and how to rejuvenate the river itself. This is for Kerala. Then this is the project which I'll be talking about. This is one of our pilot project. It's first of its kind, and a lot of cities are trying to emulate this. So this I will talk in detail. Yeah, this is the project which we installed. This and replication of this in different variations we have done in across several places. This is one small project in Coimbatore. So the scale you can see, it's about one and a half a ton to 1.5 tons to something like 30 tons and above. Now we are doing a larger project for Goa, which is something like 250 tons per day. So the whole state of Goa, we are doing solid waste management there, advisory support to the government of Goa. So this is one more thing which is slightly deviant from what we as civil engineers think is always brick and mortar type of thing. This is a software which we did for the Ministry of Housing and Urban Affairs to help practitioners, that meaning the government, the urban local body, or the consultants, to take decision on the right technology for a particular place. So it's called the SWAT, Solid Waste Appropriate Technologies software, which is on the Swachh Bharat website. So this is this was done. It was launched by the Union Minister at that time, Mr. Harmendra Puri, and it's now available on the website. Now we are doing the second part of that upgrade of this with a lot of other features. So you may have to watch out for that. It might come out sometime in next 1 or 2 months. Ideally, it should have been already launched by July, but because of COVID, it got delayed. What you see on the right is the Swachh Bharat Mission Municipal Solid Waste Management Manual, which is normally referred to as the Bible for SWM. No, this is a handbook for practitioners and meant for everybody who generates waste or manages waste. So we have been part of the technical team which authored this document. It's called the CPHO Manual 2016. This was made to help practitioners comply with the SWM rules 2016. So this is a good book to refer to if you want to know anything about solid waste. This is the project which we designed in Karnataka, the hazardous waste project. Is one of the only types in India, and still considered one of the best. It's been running strong since last 13 years. And we are doing a similar project for Goa, for the Goa state state government. Yeah. So, well, all aspects of civil engineering would come when you do these projects. So it's, although it looks like an environmental project, but mostly it's all civil engineering thing, and then you build in sustainability into it so that you don't, it works long term as per what you envision. So when you look at sustainability, what comes into your mind? It typically what we would say is, okay, technically it should work as we design. Now, there are a lot of variables in an environmental project, because unlike other branches where your input is mostly defined, look at electricity. If you say it's a 220 volt or 230 volt, it might go plus or minus 15%. And if something goes wrong, you put a stabilizer or a UPS to take care of the variation. So you can do some amount of control. Look at any process factory. You put some particular grade of plastic, the variations is not much. And look at steel. Steel, for example, if you use a certain type of ingots, you will get a particular type of, and you adjust the process, you will get a particular type of steel. But when it comes to environment, this is something which we can't define, for a simple reason: the raw material is not in your control. If you look at pollution, wastewater pollution, for example, in the morning, if you look at it, the wastewater would constitute mostly fecal matter. At somewhere around 11, you will get, when your washing and laundry is going on, you will get more of detergent. Sometime during lunchtime, you get more of food waste, and then the cycle goes. And the flow also fluctuates up and down. You cannot define. As environmentalist and a wastewater engineer, we would simply say the wastewater is having a BOD of this or COD of that, and the flow is this per day. But if you look at an instantaneous flow, it just goes up and down. But if you look at the effluent standard is very precise. As far as the law is concerned, they usually say 20 BOD or 10 BOD, nitrate should be this much, your ammonical nitrogen should be less than 5. So all precise. So what it means is, variability in the raw material does not give you any relaxation in the output side. So this is where environmental, this one becomes a little difficult for planning and designing. But yet, for sustainability, it has to work. Now, so this project is waste to energy, which is Nasik, which we have done. It was a 20-ton project aimed to generate around 3,300 electrical units on a small land of 0.6 hectares. And it has a multifold this one. Other than energy and waste management, it also sinks about 2.8 tons of carbon.
Praveen,
Yeah,
sir?
tell me. Hello?
Sorry to interrupt you. The PPT is not visible. Please again, try to present.
Okay. Let's see.
Just now only it went.
Okay, what should I do? Should I say stop sharing? Should I share once again?
Yes, sir.
Yeah, let me. Is it coming? Hello?
Go ahead, sir. Yes. Go ahead, sir.
Yes.
Yeah. So, why is this project interesting? If you look at the relevance of this project, if we look at it from the Bangalore context, when I don't know where the audience is from, but if you relate it to your own place where you live, the water bodies are polluted by sewage, untreated sewage going in, septage coming in, and things like that. So, water is polluted irrespective of whichever place we are talking about. Now, solid waste is a major problem in all cities in a country like India. Bangalore, of course, we all know the problems, but generally across India, solid waste is a major issue, and these solid waste also needs to be treated. Now, solid waste means the organic waste becomes a major problem, because once it's mixed with dry waste, the dry waste loses out the utility part of it. Then electrical shortage, of course, India is now quickly ramping up its renewable energy and other thing, but generally power itself is a major issue. So if you see this several news cuttings, you will see from everywhere, it's across Delhi, Maharashtra, Bombay, Bangalore, everywhere you have problems with electrical power, and it's increasing cost. Then the fourth problem, which is the most difficult one, is about the finances of any urban local body. They do not have, generally all urban local bodies do not have the money to, they are normally that way poor. Now we have the situation where in Bangalore they are not paid salaries for 6 months. So that's the extent. There are not too many city corporations which are rich. And if you could give them money, then probably even a richer fellow would also want it. So if you look at the core problem, you have water pollution, you have solid waste pollution, you have energy shortage, and you have financial difficulties. So that is one of the reasons many places contracts get closed because of non-payment of arrears. So if you look at a project of sustainability, any one of this can make a city not pleasant to live in. So typically when we address a problem of solid waste, we look at it from a blinker of solid waste management. You look at wastewater, you look at it from an STP and things. So it's always a limited scope for you. Now, this one project demonstrates the combined treatment of black water, which is septage, and organic solid waste using co-digestion or co-fermentation. So two problems are tackled already, wastewater and septage. Then you produce clean energy by using the energy content. So you are also addressing the power problem. And if you see the electricity is supplied free to the Nasik Municipal Corporation. So to an extent, you are also alleviating the fourth problem of finance. So thereby you are demonstrating a project where water and waste is treated environmental friendly, while generating power and also generating money. So this is a project. So you have organic solid waste and the wastewater going into a biodigester, and the methane is burnt in a combined heat and power plant, and the waste heat is taken back to increase the temperature within the digester. So thereby you can assist in the thermophilic reactions. And the water itself is treated and taken back, reused in the digester process, and the sludge is converted into fertilizer. So if you see, the whole the input and the output are all controlled. So your methane is burnt. Methane, as you know, the GHG potential is around 25. Now, so when you burn it, you are actually reducing this harmful effect of methane produced by untreated solid waste and wastewater. which is going straight into the environment. So it's a climate change project also. So these are the salient features. I'll come into the details. How did we start this project? So first we did a feasibility study of such a project. Actually, we evaluated almost 7 locations within India, right from Jammu to Goa, Bengaluru included. We checked out on where is this project feasible, because this pilot project we wanted it to succeed. Now, everywhere we have this waste problem, water problem, and money is anyway always an issue. Electricity is also an issue. So all the 7 were from the raw material and the utility point were all viable candidate. But why we finalized on Nasik was the friendly and the willingness to work with us in this project. You need a very conducive situation from the authorities to ensure that this project is kickstarted there. So among that, there we found the interest although every city was interested, the best interest came out from this Nasik Municipal Corporation. So that is why we finalized on this place in Nasik Municipal this thing. They already had assured waste. They had about 400 tons of plant. There's one more plus point. Eco Paradigm was working with Nasik project, Nasik Municipal Corporation from 2009. So we already had a familiarity with the team there, the waste generation, all those things we were familiar. And the place was our we had actually worked on operating the facility for almost 1 year in optimizing the project. So we had some familiarity in that place. So what we did a lab scale study initially. We collected the food waste samples and a sample. We also picked up septage from the public toilets which are available within Nasik Municipal Corporation, and then did lab scale study, and we analyzed and we found. Is it coming?
Sorry for the interruption. Again, the PPT was.
Oh, it's again gone. Okay.
So, dear participants, I request once again not to share your screens. Dear participants, I request once again not to share your screens. Thank you, sir. You can proceed.
Yeah, just let me get it.
Sir, sorry to interrupt you. One advice for the participants: you can pin the screen of Mr. Pravinjith, so that what happens is the screen will not change. I request you all to pin the screen of Mr. Pravinjith K P. Okay, so on the this thing, screen there is option pin to screen. So if you click that, so the screen will remain intact. It will not change. I request you everybody to do that. Please pin to screen. Yeah, so that will lock the screen and the changes will not happen.
Is this visible now?
Yes, sir.
It is.
Yes.
Okay. Yeah. So we did the lab study, and one of our partners for the study was this Birla Institute of Technology, Goa, BITS Goa. So they did the study for us, and we estimated that you would get something like 2,200 cubic meters per day with a ratio of 1:1.5. So that was decided for the design of the larger plant, and the specific gas field. These are all field studies. So typically what happens in most of the municipal corporations, whenever they go for a solid waste management, they just take standard designs and the consultants make a quick 200-page DPR without doing field studies. So I'm trying to highlight the importance of data acquisition and real-time data from the particular place. That is one of the reasons why we prepared the DSS tool also, decision support tool, because normally each technology is specific for a particular context only. You cannot have one size fits all type of approach. So with the data in hand and the field studies which we had, we designed the project for a 20-ton solid waste combined with about 10 tons of septage. Because otherwise the septage would actually flow to the river Godavari and pollute, and we wanted a very sustainable mechanism to treat solid waste. Is it screen is visible?
Yes, sir. It is not visible.
It's not visible.
Something else happened.
Oh.
I think they are trying to some thought. They are clicking some present no, so that it disturbs the
Okay. Let me.
We have to pin the screen. We are requesting to pin the screen also. But I think once again you can present. Yes, sir. Go ahead.
Yes, visible. Yeah. So, like all biomethylation plant, we can only handle segregated organic waste. So we identified, we did a mapping or inventorization of this the segregated waste which is possible. So we getting segregated waste and depending on an household waste was little difficult because there are a lot of challenges. So we identified bulk generators. So we found about 1,500 plus restaurants, small restaurant, canteens, jail, printing press, army canteens, etc., which would give us food waste, food and vegetable markets and things like that, where your chances of getting segregated waste is very high. Organic content will be very high. So we did a mapping. We also found it. I'm talking about the study was done in 2013-14 time, where the law was not that stringent. So then at that time we realized almost 50% plus 60-70% of the bulk generators were already practicing this wet and dry type of segregation. So that was an encouraging thing. So once we realized we have a pretty good chance of getting the segregated waste, we sized the plant in such a way that we don't touch the top, the maximum, because that is running into project risk. So we reduce the size of the plant to such a way that it is 20 ton we will get anyway without any major effort. So 20 tons of solid waste. We had a lot of public toilets, which were initially the municipality were carrying the septage from these things and disposing it off in their STPs. Typically in other cities, these septage is taken and applied on field, which is not a very good practice, environmentally good practice. So septages was also identified. So we made an inventory of the septic tanks and also made a calendar for them so that every day at least 2 tankers would come. So that means your septage is equally getting treated. So we made a system where we had the raw material, the waste, so organic waste, solid waste, and the waste septage also was clearly defined, and we know who would cater to our project. So this is one. Second thing, once you get it, there's still a chance that you might get some contaminants like plastics or spoons and things like that. So we had a segregation table. So finally, the flowchart is like this. You have a segregation table and you have a hopper which will feed to a shredder. 2 types of shredder. One, it will do a larger size, 25 mm, and then it goes into a 5 mm type of shredder. Then it goes to a food waste tank. So there's a food waste tank separately. Then another side, we had a septage tank where the tankers will bring in septic effluent from public toilets and feed to a septage tank. And so we have a stock of both the raw materials. And then we have a slurry feed tank, which will be the place where you mix in the right dosage. So you saw in the earlier study, 1:1.5 was the sort of preferred combination. So we used to mix it. Now, like I told you, raw material in a lab is different from actual practical things. Sometimes when you get septage from a toilet, it will be mostly water. Sometimes you get very thick sludge. So then you need to have a small laboratory in your premises which will analyze this and mix it appropriately, roughly having a sort of framework that 1:1.5 gives you optimal gas production. So once we got the slurry feed tank, which mixes it and keeps it in continuous circulation, that is pumped into a digester which can handle totally about 30 cubic meters of substrate. And then from the digester, the gas, as it's got a balloon, the gas is stored there, and the gas is cleaned up using a dry scrubber, and then it goes to a gas engine, CHP engine, and then the heat from the waste heat from the flue gas is recovered using a heat exchanger, and it goes into the digester to warm up the water. So warming up to 50 or 55 depends on how the gas is this one, and you get a better conditions for the bacteria to grow and produce more grass. So then the electricity itself is produced at 440 volt. It is transformed to 11 kV and sent out into the Maharashtra state electricity grid. So there are times when the gas engines won't work because of some fault, in which case we have a gas flaring system to burn off excess gas. So that there will be a pilot flame, and it has a pressure control, and it will automatically start. The digester, the liquid from the digestate, the digestate itself is taken to a press and the centrifugal thing, and it is dried to about 60-70% moisture content, and that sludge is taken into a sludge drying bed where the water is removed. The sludge becomes a valuable fertilizer. The water is taken back into the process. So this is what happens. So you see, these are the typical situation. So we had to do the routing chart and all for the vehicles, because when you're doing a solid waste plant, it is not just pure biodigester. You have to look at the complete nitty-gritties of the whole system. So right from planning of the this one, we made the design of the whole plant with all the nuts, valves. You need to have many controls other than the flowchart. Flowchart you saw only was a block equipments, but then there's many of this non-return valves and pressure reducing thing, pressure release valves, because safety of this is a big concern. So all these were done, and this is the electrical part. So here is where our typical civil engineering stops, and it becomes what we call general engineering. So when we come out of as civil engineers, we normally look at everything from the point of RCC, concrete and steel, and bricks and mortar. But once you get into a project, almost every aspect of engineering, the line which divides us as civil, environment, chemical, etc., is blurred, and everything becomes what we call GE, general engineering. So all this is done because you can't have a team of everybody going there and doing everything. So it should be one or two. So a typical project engineer sort of understands everything. So these are some implementation photos, including the toilet there. The toilet in the premises itself drains into the septage tank. So what you see is the erection photos. What is in the second photo, what you see here is this glass fused tank, steel tank. It's an 18-meter dia, almost 8.5 meter height. And what you see here on the top is the balloon, the gas balloon, which stores about 350 cubic meters of gas. The digester volume is around 1800 cubic meters. 1800 cubic meters, roughly about 60 days of HRT is what we have taken in the design. So about 350 cubic meter of biogas can be stored here. All these other things are all this ancillaries to that. You have, this is what you see here is a shredder platform, the crush, this is a shredder, there's a crusher there, and it pumps. And this green pipe which you see here is the digestate one, and here there is a centrifuge for drying. So these are the gas filtration system. The gas comes here, you have the scrubber and a moisture remover system, and then it goes into the generator. So this is a generator room. There's an electric meter room to measure how much electricity is generated. You have a drying bed with 4 compartments which will dry up the sludge, and the liquid goes into a lined pond which is again reused back for in the digester for mixing and water control. So this is a transformer yard which is transforming the voltage from stepping up the voltage from 440 to 11 kV, and it's evacuated to the Maharashtra state electricity grid. So you have a lot of panel rooms to monitor the health of the plant, mostly the electrical part. That's the most expensive one also. And the project was inaugurated in 2018 towards the end of the year. Now, all this is about the technical part. Now, all this would collapse if the stakeholders in this project do not get benefit. Now, this also has to be done by the consulting company, that is EcoParadigm has done it. So here the stakeholders are the municipality, which generates the which is mandated to treat the solid waste and the liquid waste. One, then you have a private sector operator who is running the project. If any one of them feels there's a loss, the system will collapse. So if the municipality feels that it is paying extra, that project is going to be killed. And if the operator feels that he is being cheated, he deserves little more, and he is not getting the right profit, he will also stop working. So on the left, what you see is a modeling of Nasik Municipal Corporation. So typically in any municipality, if you see, right from collecting the solid waste from the houses to taking it to a process plant and treating it there with all the residues being handled, it will cost you anything higher than 3,000. For example, Bangalore would spend about 5,000 to 800 rupees. So we have taken a very conservative estimate. 3,000 rupees is what they would spend, including transport, processing the waste, and managing the digestate, the residue, the sludge, and the compost, and all those things. So roughly about 3,000. Now, if you look at, if they're spending 3,000, they are getting around electricity of 3,300 units per day, which means an monthly offset, a daily offset of around 20,000 rupees. So when you say 20,000, and if you look at 3,000 rupees per ton, to handle 20 tons, they would have ideally spent 60,000 rupees per day, whereas they are getting back 20,000 rupees worth of electricity back free of cost. So in effect, for them, it only costs 40,000 rupees comparison to 60,000 if they had spent as business as usual case. It's a very good solution for the Nasik Municipal Corporation. And we are also not discounting the almost 10 tons of septage, typically about 5,000 rupees, 1,000 rupees per day is what they would spend to get the waste, the septage, that we are not added to this. So 40,000, 20,000 reduction in their normal operating cost. Yeah, so that's a good deal for Nasik. Now look at it from the operator point of view. From the right side gives you the operator's thing. They would be spending close to around 39,000 rupees, 40,000 rupees per day if they are doing this. Now, whereas if you look at their actual cost, if you take the septage management fee of 5,000 rupees, they are actually, their cost comes to 34,000. In comparison, if they get the, and so the actual cost comes to 1,715 rupees per ton for the operator. He is charging around 2,000 rupees. So that means about 295 rupees profit he is getting. So he's not losing money. Of course, if you had put a conventional system, he would have got 3,000 rupees per ton anyway for collecting the waste and processing. Hello, is it stopped?
Sir, again, there was interruption.
Okay.
A person who had entered now.
Okay.
A person who entered now, I think he misplaces the presentation.
Okay. Let me start again. So where was I? Did you hear this part, the Nasik part, where they save around 20,000 rupees per day? Hello?
Yeah, sir, completed that.
Yeah, okay. So from the operator perspective, they also tend to make around 17% profit. Now, this is for this project. Ideally, like I told, if you are comparing with Bangalore, then they would be, the Bangalore City Corporation would save around 50% of their money. And this person, the operator who's operating this type of project, would also make a solid profit. No? So it's finally, the way we look at environmental project is, we don't really look at it at profit. We will say, okay, this is the current cost. How can we share the savings? If both the parties share the saving, they have interest in sustaining this project. So financial sustainability is one very key element of environmental management. So this is the project which was launched and it is working. Unfortunately, this year, since February, we are in trouble because the solid waste collection because of COVID has landed up in trouble. Nasik is also one of the most affected places, and the workers and the waste itself, per se, is getting diverted off. So this is one situation. Of course, but being a biomethanation it will not last long. Somewhere it will again recover. But otherwise, the plant is a good model. Now, when I look at it from the case for India, now how is this pilot project relevant to India? Now, if you look at India, as you know, India has got this major solid waste problem, and this is a wastewater treatment solution. Only roughly about 20% of the water is treated, and 40% large cities and only 8% in small towns. So roughly this is the treatment data. So by large, 80% of the water is not treated in the country, treated to a tertiary quality. So you have a vast potential for this project. Now, what has happened in India now with the Swachh Bharat mission. A lot of people have gone for individual toilets where sewer lines do not exist. I'm talking about rural India and many of the smaller second tier and third tier towns. Sewer lines are not there, so everybody has gone for this twin pit toilets and with soak pits and things like that. Now you have built it, we are good, everything is nice, but after 2 years the soak pits are going to get dried, filled, and then the septage starts becoming a problem because the septage is going to contaminate the groundwater. So you need to ensure that the septage is safely treated. So a lot of states have taken up fecal sludge management as an initiative, Telangana, Andhra Pradesh, Karnataka also. Now you could use, see, all these places also have wet waste or the organic waste problem. So if you have a model like Nasik, what you can do, you can have a single project for this which can handle the solid waste plus the septage. Now this is a very good model from that perspective. So this is what it is right now. You need solutions for almost 32,000 MLD, and sludge of 154 MLD is what is the projected figure for India. Now, what it means, if you're going with a conventional system of sewer line and STPs, to run an STP, you need electricity. You need, if you're doing, assuming there's India is one large, big area, and forget about all the geography, the states and the administrative boundaries. If you're putting one very large plant of 33,000 million liters, to run the plant itself would require about 5.6 million units per day just to run an STP of any technology which you read, and you would need one project, one area of 8,200 hectares, which is substantial. Of course, it won't be one single project; it will be distributed across all these 6,000 plus small towns and almost 6 lakh villages. That's what will happen. But still, this is the land bank which will go towards establishing sewage treatment plant. And running a sewage treatment plant itself would generate almost 13,000 tons of CO2. From a climate change angle, even STPs do generate CO2. That's something we should imagine. And electricity to run it, the 6 million unit to run an STP also will in turn contribute to emissions. So you see, that's the important part you should see. We pollute, you leave it untreated, you will cause emissions. To treat it, you will also cause emissions. It may be substantially, little bit low, but still there is a. Now, solid waste per se, almost 1,43,000 tons is there, which is not handled. So you see the numbers there. Only about 12 million tons is being treated per annum, and not collected, not dumped. You can see this. So these are all potential solid waste which can be handled by this country. And if you are putting up typical compost plant like the ones you see in Bengaluru or any other city, that itself requires another 1,000 hectares. So land is needed to do this, plus your problems of community solid waste management within communities and all those things is another issue. And solid waste management itself will generate carbon dioxide, and the electricity itself in turn will generate emit this one. So the electricity required for solid waste management is another almost 1 million unit. So there you have about 7, and this is 8 million unit is needed to handle the current solid waste and the liquid waste in India. And the land you require is, you saw that. So about 9,000, 10,000 hectares of land is necessary. So if you, this is the situation for Karnataka, because I just put this data here because I thought most of the people participating would be from Karnataka. Similar situation, nothing changing. It's only slightly proportionately lower. Typically about 6 to 10% is what is the situation in Karnataka of country. Now, what if I summarize this? It means we would have wastewater generated from this would be about 3,777 million liters per day, and sludge will be around 14 million liters. Emissions due to this treatment would be about 990, and 388 tons of carbon dioxide would be from the electricity point of view. Now, this is solid waste, and similar numbers for the emissions from land. And now, if I put a single project like the Nasik model, I'm not saying that it will be feasible for all the place. It has to be selected, designed. But assuming that the model conceptually works, that is, you have a single project which can handle the septage and it can also handle the solid waste. What it means, you see, Here in black, what I show is the national numbers, and the red represents the figure for Karnataka. You can just see this waste area. Instead of 8,200 hectares, we would need about 620 for Karnataka, and energy 5.9 million units. You would require only 0.5 in Karnataka. So this is the status for India, and this is what it means. It means instead of consuming 9,000 or 10,000 hectares for having two separate conventional projects of composting plant and STPs, if I go with a NASIC type of model, which is a combined model, you would save around 2,100 is what you need for country. So almost 1/4 of the land you can manage both. And if you look at electricity, this is conventional business model. 6.6 million unit is what you would need if you were doing with the separated model, whereas this is a consumption and this is generation. So you would generate about double the unit which you would have consumed otherwise you would generate. So that way it is a very good power generation project also. So that's the difference. You see, 6.67 you would consume to treat a problem which human beings have created, and in this case, by using this combined concept of co-digestion, you can actually generate double what you would have otherwise consumed. That is one. And look at this, 20,100 tons of carbon dioxide you would have generated in a day by scientifically treating solid waste and liquid waste in compost plants and STPs. Whereas what this does, it sinks 10,000. It's like as having a carbon sequestering project which can sink 10,000 tons. So it's got a threefold advantage, where you on one side you go 20,000 up, you are having 10,000 minus. So 30,000 advantage is what you're getting with this type of model, combined model. So that's the beauty of this project. Plus it generates money. That's the key thing. So any questions? Hello?
Sir, there is one speaker, one of the participants, he says, can we use any other dry waste and septage to produce electricity?
Only if it's organic. Only if it's organic, not paper. This thing. So you need to have a volatile fraction for it to work. Hello? Dry meaning, what did he mean? Leaves, is it? Or dry leaves and things like that? Or is he talking about paper, plastics and things like that?
He says except food. Other dry waste.
No. Paper, plastics and all you can't do. See, this is a biodigestion. So anything which can be degraded only can be used. Okay. So for the other one, for the drier fraction, like what he has written, paper and plastics and all, there are other technologies. So that is where if they can go into the Swachh Bharat site and download this SBM tool, you can actually find out what is good, or you can download the manual which tells what can be used. And ideally paper, paper recycling is a very big business. Almost 90%, 95% of India's paper is recycled. It's very valuable also. So there's no fun in digesting, putting into a biometrization where it will not really contribute much. But paper recycling would actually contribute much to the economy and the climate change.
Okay, sir. There is one question. How much methane gas is produced from a kg of food waste?
So per kg, approximately you can get about 350 to 600 liters.
Okay, sir. There's one more question. If we plan for a decentralized processing unit for a city, how we can carry out the design work?
I don't get you. If you are planning for some city, how can we?
If we plan for a decentralized processing unit for a city, how do we carry out the design work?
How can we do the design? How can we do the design work? Is it? Yeah. No, that's precisely, you have to follow the simplest thing I would say is to read that SWM manual 2016 that gives about a 7-step process how to do for a city. Okay, the key part, see, understand something in these type of projects, like I told you, the raw material is variable. the most thing which can cause the failure is not really the technology part. It is using the good technology for the wrong project. So technology wise, everything is good, but if you don't use it appropriately, they fail. So most of the projects in India have failed only because of that. All technologies are good, but it is not applied appropriately. So you need to start with the data, sound data. Don't go with whatever is given by the municipality or some past research and things. These are all sort of fictitious, is what I would say. So you need to have your own data and then plan it. So you see, even although biomethanation is an known technology, biomethanation of sewage is also known. Everything, it's a very old technology, I would say. But yet we got the inventarization study done. We did the field lab scale study done. And then only we started designing it. And even in the design we have built in, you saw there are 2 tanks where you have the septage and you also have the food waste tanks. So there, that means we have not just taken 20-ton solid waste, 10-ton septage. We have got that 1:1 the ratio, and then started doing the design. No, we still do a mixture at plant.
Thank you, sir. There is one more question. What is the basic criteria for implementing this project? This project is in Nashik type. Okay. Is it population of that place or status of that place, like municipality, corporation, village, etc.? Is the question.
No, that's what I told you. We had this concept that we like I told you, the relevance. Solid waste is organic solid waste is a major problem. Wastewater is a problem, and money and energy is an issue in this country. So we decided to evaluate about 6 cities across India. Okay, right from North Jammu to Trivandrum to Goa to we checked up with Chennai and Bangalore also. Bangalore, Hubli, etc. And then, so it means problem is there. There's absolutely no decision. But the reason why we went to this pilot to Nashik was the favorable climate. When I say climate, is not the weather climate, but I'm talking about the climate from the establishment, the municipal corporation. For this, you need clearances, you need support, you need faster approvals, and an interest. Now, if a city is not very interested, you can't do much with this project. It will be there, but you can't do much. So every stage, you got land immediately, they got decisions very easily. So these were the reasons why it happened in Nashik. Because see, you don't want to get stuck with the project where just because of clearance, the project is just in a limbo, and then you can't demonstrate anything much. So we wanted a project to be proven technically and financially, but for that, the clearances and approvals are one major important thing. Otherwise, your project does not even start. So that is why we went to Nashik.
Thank you, sir. There is one more question from a participant here. How and where the residue of the waste management can be discharged?
How and where the residue of this particular project? Yeah. So here, see what are the residue here? The gas residue is anyway getting burnt. Okay, it's getting burnt. The methane part of it is getting burnt. Of course, when you burn this, you still get CO2, which is vented out into the atmosphere with a proper chimney. That is one. So you're limiting the harmful effects of methane. That is one. The other residue is the liquid and the solid. The liquid and the solid come together as form of digestate. So that is actually you have a solid separator, and the solids with some amount of moisture is taken to a sand bed, where the sludge drying bed, where the water is drained out, the sludge gets dried, and the sludge is a compost. So solids, organic solids, get into a field as a compost material. The liquid which is coming out from the centrifuge process, from the solid liquid separator, as well as from the drying bed, is taken back because you need to add moisture. So it depends on what solids you get. Now, it's not that you always get the type in a slurry form. So you need to add water along with the food waste in a ratio 1:1 to dilute it. Only then you can put it into the digester. It will not work otherwise. So the water is reused. There will still be an outage from the water because you can't technically use back all the water. So that water is used within the premises for the plantation. So this is 2. Now there is one more thing I have to tell about this. Now what happens is, because you are mixing the septage within with the regular food material, there is a chance of pathogens which come in. No, so when I use this sludge, you can have ascaris, you can have all other fecal pathogens which can propagate diseases. So what we are doing is we have an hygienization project linked to it. So which is also a unique thing because the government of India is coming out with some policies regarding the hygiene standards of compost and sludge. So here the sludge is sort of getting, you need to handle it in such a way that the ascaris do not live. So in a ascaris worm eggs, for example, worm eggs have a shelf life of around 6 months. So which means in a typical STP, let's say, when you take out a sludge from the filter press in, let's say, every day, every week, or whatever period you do, you have a filter press dried out material which you say is a valuable compost. Typically any STP, if you see, they will say that the sludge, dried sludge, is used as compost. Now what it means is when I take a dried sludge today and dry it up in a filter press and keep it for 15 days or something and take it to a field, I am carrying active ascaris eggs and other related material into the field which can propagate diseases unless it is proven that it is scientifically disinfected. Now you can't put chlorine to disinfect, you can't do ozonization, you can't do ultraviolet because there's a certain, you can't do microwaving. So these are all the different types of technologies to disinfect, but you can't do that because the sludge is a cake. Even if you do microwave, only the top gets this thing. UV will not work at all. Ozone you cannot use. So so hygienization is integral to this project, which is also part. It is still not commissioned. The design is done, and that is going to be used with that. The third thing yesterday Dr. Arvind Bashyam was also referring to. One of the major problems in India, and for that matter, India and other developing countries, and including developed countries, is that the land is getting degraded. So there is something called achieving land degradation neutrality. It's a program of the UN, and India is also a signatory to it. So it is about reversing the land degradation occurring. So what it means is India is committed by the year, I think 2030 or something, we would reverse all the land degradation. So you would have seen news article which says that the productivity and yield of agricultural field is falling on a day-to-day, year-to-year basis. You don't get the actual yield what you used to get about 20 years ago, thanks to commercial fertilizer. So you apply the same fertilizer, your yield is down. So, and that is one. So there is a project currently going on in Maharashtra and Madhya Pradesh. It's called the Pro Soil Project, which Eco Paradigm is part of it. So we are going to use this sludge from there to achieve this end of reversing the degradation. Yeah, so that's also a linked project. Another thing which I want to say, strongly emphasize, somebody asked about how do you do this in a city. See, technology is something which we can get. There are a lot of patented technologies, a lot of good technologies, but where it fails is in the contract management. So here, when I say I can generate around 3,300 units, I have not said so. We have did this analysis. We found a certain cubic meters, 2,300 cubic meters of biogas from a lab study. When I transfer it to a field, I assume the same ratio continues. But when I do a tender, I cannot say, ask a supplier to come and say, you have to guarantee 2,400 for a simple reason. The waste is related to the raw material. I mean, the gas is related to the raw material. Now, you put chapati, you get some gas. You put rice, you get some other gas. You put grass, you'll get some other gas. So how do you guarantee? Like I told you, the environmental law is strict. They have a certain end condition. They don't care what goes in. You have to comply with that standard. Now, when I make a contract and say 3,300 units you have to give me, that is binding, and because there is no guarantee of the waste, nobody really knows whether you will get 20 tons every day. Now look at this situation in COVID. No, you are not getting the required quantity of waste. So when you make a contract, you design in such a way that it helps the contractor also insulate against project risk. So this contract which you've done is that way. So when we called a contract, we said, look, we know what will come. This is our data. You guys can come and do the study. You have to guarantee what you think you can generate under any context. So this is how it is designed. So what happens is people guarantee different things. No, it's all on the confidence of the technology. So we had put an absolute minimum threshold of 1,100 units. He said, this is below this, anybody quotes, we don't accept this tender itself. 1,100 units. So you can see People have quoted something around 3,300 units also. So this is how it is. So what we told is, you guarantee low, anything more you generate, it's yours. Not, you don't have to give it to the municipality. But if you guarantee something and don't deliver, there is a penalty. That's a huge penalty. So because what happens if two bidders are bidding for this project, one decides to quote low because I've told 1,150, somebody says I'll quote 1,151. Okay, and another fellow says 3,000. Now 3,000 he does to get the job, because obviously he's generating more from the waste. After getting the job, he does not deliver, you need to penalize him. And somebody says, I will play very conservative. I am generating 2,000, I know, but I will put 1,150 so that I will not get into penalty. He also loses because there will be somebody who might quote 2,000 or 1,980 and get the job. So, you know, so it's both the risk part of it has to be done. So the contract is tailored in such a way that you don't, you can eliminate non-serious players, and you can also eliminate ambitious players who are just trying gamblers type of risk. So that's the most important part of, then everybody has to win, including the municipality. So that's something which is tailored into the contract. So as a civil engineering professional, environment sort of bounds on all the engineering part. Now here you would also need to know a bit of law, contract law, economics, finance. So then you get well rounded in such project, because environment by itself will not stand. It's not just what you see in BOD, COD. It's much more than that, because it has to work day in and day out. This is what it is.
Sir, there is one question. Sir, what is the method adopted for disposing the biomedical waste? As of now, because of this pandemic, there's a lot of biomedical waste being generated. So, what is the methodology in general which is being adopted?
In general, there is a law which is called the Biomedical Waste Management Rules 2016. I mean, the 2016 is the latest. As per this, every hospital is supposed to tie up with an authorized biomedical waste operator. So we have, for example, in Bangalore, we have two operators, Ramki and Maradi, and the operators are licensed for every year. They have to get renewed. So they have a system, a plant which is compliant with the law. So now in the hospital, you have these various categories of waste which has to be kept: yellow, white, and black. And black is a normal domestic refuse. So you have metals, sharps. So there are different techniques for it. So the yellow bag, the current COVID in the context, there's advisories from the environmental ministry, so which is there, and they usually follow that. So the yellow big is getting incinerated, and the other ones are actually sterilized, autoclaved, which any plastic which contains chlorine you cannot burn because of the fear of dioxins and furans. So all other things other than this, what can be burned, which is other than what is coming in the yellow bin, everything else is autoclaved. So an autoclave is like a pressure cooker, and you heat it under a certain pressure and a temperature, and it's completely disinfected, and then it is used for this one, landfilling. So these procedures are already very clearly listed out in the law itself. What will go where? I hope everyone.
Yeah. Sir, there's one more question. Up to how many days water from the sludge drain bed remains in the lined ponds?
How many days it will lie in the pond?
Yeah, water from the sludge drain bed remains in the lined pond for how many days?
No, that is just a stocking system, because from the drain bed it has to drain and go somewhere. So you have a tank. You have a tank where it's collected. It could be a closed tank. It could be an open tank. Open tank allows us one advantage, that some of it will get evaporated. See, water is a nuisance as far as the project is concerned. So because we don't need that amount of water, septage itself is bringing in 10 tons of water. You need another, let's say another 10 tons to recycle, because 20 ton 1:1 water means 10 tons waste, 20 tons waste requires 20 tons of water. So you need water. This water is taken back to dilute the food, and even when you're crushing the food, you may need to make it into slurry. You need water back. You can't put septage and start mixing it up. That's not a good idea, because septage contains everything, excreta and things like that. So if that is directly pumped into the digester, after mixing it, the water from the digestate is taken back for the crushing operation, and is taken. So the rest of the water is used in the gardening. So it is not, we are not really holding it, because when you hold it, see, the digestate also contains a lot of organics. It's not that everything is fully digested in a digester. Digester is a sort of preliminary first stage thing. No, it's a primary digestion. So it also contains organics which will start degrading. It will also cause stink. So we use as much as possible. The rest is like liquid manure to use back in the project. So we don't really like to hold it. So it is almost taken out on a daily basis, maximum 2.
Great. Sir, I had one question.
Yeah.
Where do you think cities like Bangalore, Chennai, Mumbai, Pune, they are struggling in handling the waste, because waste is a source, very important source from which we can generate a lot of revenue out of it. In spite of that, people are still struggling to handle the garbage, especially. Where do you think we are, lacking, sir?
No, that's what. See,
Is it the
lacking.
government policies, or what, sir?
No, it's a combination of many things. It's a combination of many things, and somewhere, these problems are like this. It starts cascading. Somewhere you do a mismatch. For example, if I can tell you some project which we have visited. You start with a planning of a let's say a compost plant, one of the most simplest rugged technology, not much of science involved there. As long as you have it's like gardening. You don't get a degree in gardening, although you have agricultural science, agricultural engineering, a lot of other thing. It's also part of biology and botany. But to run your garden, you don't need a proper degree as such. Composting is, although it's a science, it's an environmental engineering, biochemistry, whatever you want to call, microbiology and all. It's not looked at it from a science point of view. It is more like a gardening type of situation. Anybody can operate. The compost plant has become to that extent a very low tech system. So when you handle something like that, somebody thinks, okay, compost plant is simple. You put windrows, and people don't know what the size of windrows, what should be the maximum size and things like that. So you only make pyramids out of it and you plan it. Now, first thing is understanding how the data changes. We will say, let's say we say every Bangalorean generates 550 grams per day, in which let's say 50% is organic. So it comes to 275 grams per person. What it means is 275 grams, you cannot average a city like 1.2 crore or a 40,000 population. You can't just multiply and say everything is like that. We have to make allowances for peaks within the months, within the weeks. So plants have to be designed for overcapacities. And you should start planning for the future expansion at least 2 or 3 years in advance, so that by the time the new plant has come, you still have the reserve capacity. So people don't treat it like that. They look at it like a process plant, where you put 10 tons of iron, you get 10 tons of iron rods or 10 tons of iron billets. It's not like that. This is waste, and waste variations are very high. And same thing, the quality of waste is also changing. Like I said, you can have pure, I'll put an example. You have Ayudha Puja, you will get a lot of that ash goats. Now you will get a lot of, on the 9th day, you'll get a lot of lemon from the street. Now, all these are something which you can't just factor in and say, okay, lemon is also biodegradable, we put and make a lemon compost. It can't happen. So you need a planning which will sort of mix and match things, so that you get the right. For a green waste, you should have a dry waste, so your carbon and nitrogen part is taken care of. So C/N ratio, nobody does all this. So that is why it fails. So from there you start. Now what happens when it happens? When your C/N ratio is not good, if your moisture is not correct, what will happen is the degradation process. Again, consultants or the authorities, they normally take a cycle of 30 days, 35 days, 40 days. Everybody comes around saying that the compost, we have a innovative organic waste composter. In 3 days it produces compost. You can't produce 3 days compost at all. Compost is a biological process. It cannot happen in 3 days. You only shredded it, change the form. A cabbage will not look like a cabbage. A brinjal will not look like a brinjal. It will all be brown. Does not mean that it has become a compost. Compost is a fermented material. So fermented material is something which undergoes the due process of biological degradation, which will be anything between 40 days to 60 days to 90 days also, if you have not done it correctly. So this factor has to be considered during the planning of the solid waste management plan. Once that is, if that is not done, if somebody designs it for 35 days or 40 days because he saw one model like Indore model, Mysore model or something, without understanding the vagaries of his city, what will happen? A day when you get a lot of waste, you can't say, okay, you see, if you go to visit a typical mall, no? You will say parking full, 3,000 cars, 3,000 car full. The rest of the guys are thrown out on the street. You can go around roaming. But in a compost plant, waste comes in. You can't say, okay, my plant is designed for 500 ton of this character of waste, so hence you guys are rejected. You go back. You can't. So what happens? The waste just comes in. They find some place, clear it, fill it up there. Once you fill it, next day you can't handle it because all your aisles, driving space, your machine for your windrow turner, material handling device, there's no road for going in. So from there it starts. And then what you do, when you next day also you'll get the same waste. So you'll start putting it. And at one point you get into anaerobic zone. The composting is an aerobic process. So an aerobic windrow becomes an anaerobic by default. And when it becomes anaerobic, you get methane, you get stink, and it catches fire. And there your problem starts. When it catches fire, you stop the plant. And then the waste now piles up further. So then it becomes a chicken and egg situation. So the problem is because of this, that you don't make reserve capacity in a compost plant. For that, you need money. The municipalities don't have. They don't invest money on analyzing the waste. So it's like that. One shoe fits all is where the problem starts.
Thank you, sir. Thank you, sir. I think, yeah, sir. Yeah. I think, yeah, there have been a lot of questions which have been. This last question, which will probably take up, sir. There's one question on how effective is the life cycle analysis and technology TEA of biogas digesters, LC and TEA of biogas digesters. How effective is it?
So now there are two aspects to this question. You have a problem, right? You always have to compare it with a business as usual type of case. What will you do if you leave it untreated, if you burn it, if you use composting, if you use incineration, things like that? Then you have to choose the best option left over. Now, if you look at the typical waste management hierarchy, reduce, recycle, the third level comes biomethanation. So that itself tells you the answer that this is the highest priority technology for wet waste. So if you have not reduced, if you have not recycled the waste, if you have not fed your dog or cat or cow, then the next best is this, because this alleviates almost all other problems. Only if you can't do it, then you go to the next one, which is composting. Some other countries, some European countries do not allow compost to be used in field. So then what they do is they use what we call composting. They use it called mechanical biological treatment, MBT, and sort of make it into a compost and take the compost and landfill it. So when they say zero landfill, they're not really telling zero landfill. They're actually telling zero untreated landfill. So once you treat it, they don't consider it like it's a proper landfill, sanitary landfill. So untreated, see in India, what we do, what we can't handle, we just go and dump it into some quarries. That is untreated. That causes emissions. But moment you digest it, ferment it, it is a treated waste. So it does not no carbon CO2 potential in that. That's okay. Yeah. But in India, because the waste is largely that way uncontaminated, not in cities, but generally, this is a valuable nutrient for the field. So that's how it is done.
So there's one more question. Okay, can you take up one more question, sir, with your permission?
Yeah, no, definitely.
Yeah. What are the techniques used to clean the biogas released from the digester?
So you have the CO2 there. CO2, we have an H2S scrubber. Not CO2, what I'm talking about. It's a lime, dry lime. So the H2S is removed. Okay. And then you have a moisture removal system. And the gas engine is designed for a mixture of carbon dioxide and CH4, methane. So it's not a pure this thing. It's a biogas engine. The sulfur H2S is removed. H2S and moisture is where is the problem. So that is removed. Single line.
Right, sir. Thank you, sir. So, sir, on behalf of the department and the participants, we would like to thank you for giving us your time and giving us the case study presentation of the waste to energy, which I mean you had executed recently at Nashik. I think there are a lot of things which we can learn out of it. So thank you so much, sir, for your valuable time. So we are looking forward to have good interaction in the coming days with you. Thank you so much, sir. Thank you so much, sir. Thank you.
Yeah. Thank you, Manish. It was very interesting, always as usual. You can share my contacts with the participants in case they want to reach out to me. That will be mutually beneficial. Yeah. So I'm always available for you. That's not an issue. Thank you, and wish you all the best for the next 3 days.
Yeah, thank you, sir. Thank you. We'll share your details with the participants. Thank you so much. Thank you so much.
Bye-bye.
So participants, we are ending. Participants, we are ending today's session. We'll be sharing the details of the speaker today in the WhatsApp group. So we'll also be sharing the feedback link shortly in the WhatsApp group. So please give your feedback. Thank you so much. We will be joining back for the session tomorrow again at 10:30. Thank you. Signing off. Bye.